Okay, so that is the assignment part. I don't think most of you have questions on question number one because it's quite straightforward. And this question number one is focusing completely on the last part of the section, right? So you have to define the variable, then the function, then you're looking at different values of x. So my x is equal to 2. Now for the first question here, you cannot choose x is equal to 1. And the reason is if you choose x is equal to 1, if you look at the denominator, you have 1 minus 1, which is 0. So you have a numerator and the entire numerator is divided by 0, which goes to infinity. And imagine you have an infinity as an answer. Of course, you cannot have an infinity as an answer and you cannot plot them as also. So, so make sure that you're choosing the correct x value. Similarly, you have, of course, this is all fine. So try to choose x is equal to 3 or 2 or 0 or whatever it is, up, except 1. Okay, and of course, these are all, I don't think you have a problem with this. Limiting also, extending to -1, extending to 0, extending to 1. Everything is quite straightforward. So you just have to follow this. Instead of 2, you have 1, 0, -1. Right? For the second question, you have to define t first. Okay, let me show you how do we do that. So first of first, define t, then go ahead and define p of t, which is equal to, you have a numerator and denominator. So numerator is 400, denominator is 2 plus 8 times, parenthesis again, 0.75 to the power t. And that's the way you define function. Now, if you look at this, you have to plot the function from 0 to various positive values. That means you have to plot p of t with 0 to 10 first. For the next part, you have to plot from 0 to 15, 0 to 20, and 0 to 25. So I'm just going to show you from 0 to 10, and rest remains the same. So run it. Just to make sure, are you able to see the screen now?
Yes, I can see it.
Okay, good. Thank you. So I plotted from 0 to 10. So that's for the first part, that is 0 to 10. And 0 to 15, 0 to 20 remains the same. So now, as t gets bigger, p never seems to get about 200. That means we have to check the limit. Limit p of t. Now you are limiting to a variable t. Now you have to tend that limit to infinity. So to have infinity, you just have to use INF. You see that it's 200. So you can even check for say 1 billion. Okay, still 200. It's okay. We have to use VPA to have our answers in decimals. See that it's still 200. So that means using that equation. So remember, this question is applied math formula, applied math model, where p is animals as a function of time t. So you are checking the population of animals with respect to time. So if you increase, if the time is infinity, you just have 200 as number of animals. So that's what you're trying to see here. And I don't think most of you have questions here, but I see there's a question in part 3. Now part 3 is not as simple as you read, but if you read it correctly, it is very simple. Now let me make a comment. Now, P of t is an equation developed to fetch population for, of year 1960. Now 1960 is initial year. Similarly, Q of t is an equation is an equation to solve or to fetch the population in the year 2020. That is the current year. Now, if you want to look at the population in the year 1970 using P of t, this is what you have to do. 1970 minus 1960, which is equal to 10. Oh, my t would be 10 now, right? T is 10. So you have to simply find P of 10. That's all. Now read the first question. Now the first question is asking you to estimate the world's population in 1960. That means you have to use both the equations to find the population in the year 1960. Now to find the population in the year 1960 using P of t is simply, let's say, A dot dot dot. Oh, this is 197. So you are supposed to find the population in the 1960 using 1960's formula. So that is 0. Now what is your t value? T is simply 0. Now you are supposed to find P of 0. That's all. Okay, that is A. Let me make it more representative. Okay, now using Q of t. Okay, now when it comes to Q of t, you are finding the population for the current year. That means to find the population in the year 1960, you have to go back how many years? So 2020 is, no, 1960 is what you have to find. 1960 minus 2020, where 2020 is your Q of t's formula. Okay, so that was nothing but 80, right? Negative 60, it is 60. So you have to find Q of 60 there. That completes your A. Third question, A part. Is that, did you get it? And if anyone of you could answer that?
Yeah, that helps a lot more.
Yeah.
Yeah,
Okay.
for me too.
Yeah. Okay. So let's look at B now. Now, after this, you would have a very good idea. Now, use each model to estimate the world population now. Now is nothing but 2020. Now, if you want to find the population of 2020 using P of t. Now, remember, P of t is derived for 1960. So that means you have to go forward. So you have to find 2020's population using 1960's formula. That is 60. Now, what are you supposed to find? You're supposed to find P of 60. So P of 60 is going to give you the population of 2020 using 1960's data. Now, similarly, you have to also find 2020's population using Q of t. So 2020's population using 2020's equation, that is 0. So you have to find Q of 0. That's all. That's all. So B is done. Now for C, use them as doomsday. Now go ahead and see what a doomsday is. I'm not going to give you the answer directly. So what you're supposed to do is you have to limit both the equations. Let me do one and you will understand the rest. So you have to limit both the equations to infinity and find out when the population goes to extent. I mean, when the population would be 0. Oh, still have the same thing. Oh, I don't have P of t. Okay. Should have P of t before I do. Define t. Now let me go ahead and see what my P of t is. So my P of t is, I have a numerator and a denominator. My numerator has 30. My denominator has 3 plus 7 times exponential exp of negative 0.03 times t. Okay, make sure that you are defining the function or the equation correctly. If you see that, you have 10. So go ahead and see what a doomsday model is. Okay, I'm not going to leak the answer. So try to apply limits to both P of t and Q of t and see when the population would go away. Okay, I've leaked the answer. So you just have to check when the population will not be there. It has to go to 0. Okay, that's simply a doomsday model. So doomsday is a day where there's no people at all. Okay, just apply limits to both P of t and Q of t, and you will have one of the equation giving you 0 as the limit when you tend t to infinity. Does that answer your questions on the assignment?
Yes.